All right. Let's see here. Let's get going. I'm all flustered now. I just got inside with the dog and had a bunch of emails, Green Bay testing and stuff like that. It's like the person that was supposed to go up with me is not going to be there, so it's going to be a little interesting next Tuesday. All right, let's get going. Oh, I'm up in Green Bay, and I was supposed to have another teacher with me, but there's something came up already, so she can't go up there. So I've got like 21 students all by myself. And I mean, if it was the old ACT testing, it wouldn't be bad, but it's new this year. It's on computers. So I'm 100% sure something's going to go wrong. Anytime you have a new system, trying out a new system, you know things are going to go wrong. But that's okay. I'll make it through. All right. This way, yeah, exactly. This week we're going to be doing integration by substitution. It is a bit harder than um, what we've been doing. So hang on, make sure you ask questions this week if you don't understand something. Let's do a little bit of review from last week. This problem right here, why don't you give me the answer? Okay, why don't you work that out? I saw I had one more email, so I'm going to go and answer that. Why don't you try to come up with the answer, and then I'll be right back. All right. Well, this is the fundamental theorem of calculus part 2. So remember, if we take the integral, so let's take a look here. I need to make sure my marker's working here. Let's go with red today. Okay, so I'm going to take the integral first. Well, the integral of e to the negative 4x, if you remember from last week, it's e to the negative 4x over negative 4. Because it's e to the kx over k. That is the rule for the integral of e, okay? Which is different than the derivative, and that's why a lot of kids, they make a mistake when they have the derivative and the antiderivative. Okay, so now I've taken the integral, and that is from 0 to 1. So now I'm going to plug 1 in. So if I plug 1 in, I end up with e to the negative 4 over negative 4 minus, and then I'm going to put 0 in here, but if I put 0 in here, negative 4 to the 0 is 0, e to the 0 is 1. So that would be my answer. Let's see here. So this negative, if I bring that negative up here, that's a negative 4 on the bottom. So that would make that a positive, and that would be letter D for my answer. Okay, remember, when you take the derivative, or the antiderivative, it's f of b minus f of a. Okay, does it starting to ring a bell? Okay, I think I have one more review problem. Yep. Now this review problem, let me see if I have another one here. Nope. Okay, so now this review problem, you can't take an integral of an absolute value. So I'm looking at this problem, and it's if I could graph this thing out, which I can, I know that this is going to shift it over one place to the right this way. So it's going to look something like this. And I'm going from 0, so I'm starting, let's change colors here. So I'm starting here, and I'm going to 3, which is probably about here. So if I plug 3 in here, 3 minus 1 is 2, so this would be 2 here. This is 1 here. So all I have to do is, and that's what this problem is trying to get across, is sometimes you can just find the integral just by finding the area underneath the curve. Okay, and if it's an absolute value, I definitely can find the area underneath the curve. I think this would be 1/2 here, and this would be, this is 3 here, so this is 2 here, this is 2 here, so 2 times 2 is 4, divided by 2 is 2, okay? Base times height divided by 2. So this would be 2.5, so what is that, 5/2? So letter D again. So the concept is always, if you can't find the area underneath the curve, now there's a lot of things that you cannot find the area underneath the curve. So we had a lot of those problems on the assessment last week. But if you do come into a problem where you could graph it out and you could use geometry to find the area, that's a perfectly good way of finding because it means the same thing. This from 0 to 3 really means the area underneath the curve of this function. That's basically what it's saying. Okay. All right. Now we're going to find antiderivatives by substitution. Much harder concept this week. Substitution method, it's called U substitution. You must use U substitution to integrate a function containing something other than just an x. Just as you've had to use the chain rule to differentiate such functions. For example, in the integral 2x minus 4 to the 10th power dx, the power function contains 2x minus 4, not just x. So we have to use what's called U substitution in order to solve this problem. Now, if I was going to solve this problem right here, okay, and this is not a real difficult one. So what you do is what you're really trying to get to the point when you're taking the integral is you're trying to get to something that looks something like this, u to the 10th. If I had the integral of u to the 10th, well, that's pretty easy. That would be u to the 11th over 11, right? So that's what I'm trying to get to. I'm trying to get to something where I can take the integral of it, okay? So what we're going to do is we're going to set this problem up. We're going to let u equal something. Well, I'm going to let u equal 2x minus 4. See how this dx is there? That's really important. Then your next step is you're going to take the derivative of this thing, okay? You're going to take the derivative of 2x minus 4. So I end up with du dx is equal to 2. Well, that would be dx. That would be dx du. All right. So now what we're going to do is we're going to substitute. And there's two things you have to substitute in for. You have to substitute something in for this and something in for this. So there's two things we're going to substitute in. Well, 2x minus 4 I know is u, so I'm going to substitute that in. I'm going to say in place of 2x minus 4, I'm going to put u, so that's a 10th. And in place of dx, remember we took the derivative for a reason. So whatever that comes out to be, dx, we're going to plug that in there for that, okay? So that's going to end up in place of dx dy, we're going to put 2 there. Now, usually when we have just a constant, we bring it to the front. So I'm just going to bring that to the front. I'm going to take the derivative of this, or the antiderivative of this now. So that's going to be u to the 11th over 11. That's a u. I don't know why I put a 10. U to the 11th over 11, and then I have the 2 out in front. And then my last step is I take that u value and I plug it back in here. So my answer would be 2x minus 4 over, to the 11th, over 11. Now, how can I check myself? Remember, we can always take the derivative, and we should always get what we started with, right? If I bring the 11 down, so if and this is a good review of the chain rule, bring the 11 down, so that would be 22 times, leave the middle alone, minus 4 to the 10th power, times the derivative of the middle, which is 2 over 11. Well, that crosses out, that becomes a 2, and then that 2 times 2 is, that should have been over 2, and we should get our answer back. I messed up there, not thinking this through. Okay, let's go to the next slide. So U substitution deals with, that's where I kind of thought I made, thank goodness I had my notes here. Let U equal 2x minus 4, and then we take the derivative of that. So we end up with du, so the derivative of u with respect to x equals 2, and then we solve for x, dx. So dx equals, so all I did is I took this, and I solved for dx. So I brought the dx up over here, brought the 2 down, so that would be du over 2 is equal to dx. And then I play, that's where I made my mistake. Then you put the dx or the du over 2 where the dx was. So now, and then we take the antiderivative. So when it's over 2, it really is just 1/2 integral of u to the 10th. If I take the derivative or the antiderivative, I get u to the 10th over 10, but that's times 1/2. So that becomes, jeepers, gotta add 1. And then that would become u to the 11th over 22. Our last step is always to plug our u value back in. So that would be 2x plus 4 to the 11th power over 22 plus c. Again, if I wanted to solve this to see if it works, I can take the derivative of this, and I should go right back to what I start with. So if I bring the 11 down, leave the middle alone, 2x plus 4 to 10th power times the derivative of the middle, which is 2. So now I have 11 times 2, which is 22 on top, 22 on bottom. So I end up with 2x plus 4 to the 10th power. So I do end up with what I started with. So here's my integral. If I take the derivative of that, I get what I started with. So it's always a good thing to check your answers. Just always just take the derivative of it, and you should get back to your answer. Now, what most people have problems with is trying to think what the u value should be, okay? But the more of these problems we do, the easier it gets to figure out what the u value is. So let's say I had cosine of 7x plus 5 dx. Well, there's no way I can use u as cosine, because if I did that, that would be sine, and it's not going to cross off anything. So what I do in this problem is I say, okay, I'm going to let my u value be 7x plus 5. Okay. Then my next step, and usually I just write it over to the side. I go u is equal to 7x plus 5. Then I take the derivative of that. So du dx is equal to 7. And then I solve for dx. So I bring the dx up over here. So du over 7 is equal to dx. Okay, so I'm going to substitute this and this. So wherever I see 7x plus 5, I'm going to put a u. Wherever I see dx, I'm going to put du over 7. So here's what happens. I'll end up with the integral of cosine of u. And then wherever that dx is, I'm going to put du over 7. I'm going to bring that 7 out in front, so that becomes 1/7 integral of cosine of u. Now, we did this last week, right? We found the integral of cosine. The integral of cosine is sine of u. So then I just end up with 1/7 sine of u. Last step, plug 7x plus 5 back in for u. So my answer is 1/7 sine of 7x plus 5 plus c. Now, If I want to take the derivative of this, I will get my answer back here. And that's where, you know, just checking your answers, you can always check to see if you are correct. Okay, let's try one on our own. So this problem here, what is my u value going to be? Well, my u value, usually if you have something raised to a power, whatever's inside is going to be your u value. So I'm going to let u equal 3x plus 3. Second step, take the derivative. So du dx is equal to 3. Solve for dx. So du over 3 is equal to dx. Oops, dx. Now, I'm going to substitute. So I've got the integral, and wherever I see 3x plus 3, I'm going to put a u value there, u to the 5th. And then wherever I see dx, I'm going to put du over 3. And that usually you can pull out. So I'm just going to rewrite it as 1/3 u to the 5th. All right, so now instead of having this really tough thing to take an integral of, I've got this really easy thing to take an integral of. So that's going to be 1/3 u to the 6th over 6, which becomes u to the 6th over 18. My last step, I take my u value and I plug it back in. So I've got 3x plus 3 to the 6th power over 18 plus c. And that is my answer. Whew. All right, I'm getting back into the groove. Any questions on that? Now, whenever you take a derivative, and that's let's say you had like 2x plus 3, and you take the derivative of this, you usually get to the derivative and then dx. You're supposed to put a dx out of there. That is what the dx is. It's just saying, hey, this is the derivative of this original function. So where does the du go? It's gone because we put when you take an integral of a derivative, it goes away. So if I took the integral of 2 dx, I end up with 2x plus 3 plus c. That just goes away. It's just the way you write the integral out, but it's no longer there. Okay, because the integral of du is just u, or it's just gone. Okay, so it will not be there anymore. All right, let's try another one. Okay, this one's a little bit tougher. It tells us what to use u for. Now, I'm going to show you why you have to use the x to the 3rd plus 6. Because if you let u equal x squared, we won't even talk about that. So let's say I have u is equal to x to the 3rd plus 6. Okay. So if I take the derivative of that, I get du dx equals 3x squared. So now I want to solve this thing for dx, so I end up with du over 3x squared is equal to dx. Okay, so far so good. Is this part okay? All right, now here's where it gets a little tricky. I'm going to put u in for x to the 3rd, so I've got the integral of x squared, the square root of, and then I'm just going to put u here, right? Because x to the 3rd plus 6, that's my u value. All right. And then wherever I see dx, I'm going to put du over 3x squared. You can never, ever, ever, let me repeat this, ever, ever, ever take an integral if there's two different variables. Well, look what happens here. This x squared on top crosses out this x squared on the bottom. And if that didn't happen, something is terribly wrong. Then you use the wrong u value, because you cannot have u's and x's when you're taking an integral. So now what I really have is I have the integral of the square root of u over 3 du. I'm just going to pull that 3 out. So I've got 1/3 the integral of, and then I'm just going to put u to the 1/2 here. du. Okay, so now see how we don't have any, we have u's to take the integral of, but we don't have any x's left. And if that x squared did not cross off, we would have been in a real hurt. That's why I always look for the highest power, x to the third. If I take the derivative of x to the third, that gives me x squared. That's going to cross that thing out. So I knew right away I had to use x to the third plus 6 because I needed to cross off that x squared. It had to go away. And now if I take the integral of this, what is that? U to the 3 halves over 3 halves times 1/3. What a mess. And then that would be 2/3 here. So I cross that out. So that's going to be 2/9 u to the 3 halves, which I'm going to plug my x value or my u value back in there. So that's x to the third plus 6 to the 3 halves. And that would be my integral. Okay, does that make sense? All right, I'm going to let you try one. I want you to evaluate this. The integral of x to the third, or x squared, times e to the x raised to the x to the third. What do you think your u value is going to be? Not e, it's just going to be x to the third. Because when you take the derivative of x to the third, you're going to end up getting an x squared, which is going to cross off that x squared. So just let u, okay, in this problem, I'll get you started here. Let u equal x to the third. Okay. All right. And then I'm going to let you work and see what you get there. Okay. So if I take the derivative here, okay, so that gives me du over dx equals 3x squared. So far, so good? And that is where that is where so many problems happen because now that we know how to take integrals and derivatives, it's like, okay, do I add one? Do I subtract one? Well, when you're taking the derivative, we go down one. Okay, so I'm gonna let you continue now. Okay, so you got the second step. So continue on and see how far you get. e x to the 3 over, oops, I can't read that. My screen is over 3 plus c. Okay, let's try it out. Kind of sounds right to me. So my next thing here, I'm gonna solve for dx. So that's going to be du over 3x squared equals dx. Okay, so now I'm going to plug things in here. So I've got the integral of x squared e to the u, because I'm going to substitute x to the third, or u for where I see x to the third. And where I see dx, I'm going to put du over 3x squared. All right, lo and behold, 3x squared. Oh no, what happened there? I don't know what happened there. All right, so I'm going to rewrite it. So that gave me the integral x squared e to the u. All right. Okay, so lo and behold, I wanted to, the x squared is going to cross out here. So I'm left with the integral of e to the u du, and then I'm just going to bring the 3 out front, but that's going to be a 1/3, right? So now if I take the integral of e to the u, it's just e to the u. The integral and the derivative of e to the u is just e to the u. So I just have 1/3 e to the u. Now I'm just going to plug that back in here. What the heck is happening? Why is that erasing? So I'm going to end up with, there we go. So I'm going to end up with 1/3 e to x to the third. And that is exactly what you ended up with. That is exactly right. That is called u substitution. Let's try another one. The only way to get good at these is just to keep working at them. All right, let's try another one here. Oh, 2 of them. Whew. All right, I want you to, what is the difference between these 2 problems and the ones that we've just done? Okay, what's the difference between these? Yeah, it has boundaries. That means we have to come up with an answer. Okay, I'm going to do the first one. This one looks a little bit tougher. So if I did this problem, the first thing I look at is, okay, this is going to be my u value. So u is equal to 4x squared plus 1. So du over dx equals 8x. Oh, that's awesome, because look at that 8x sitting up there. I know I'm going to cross that out. Okay, so I end up with du over 8x equals dx. So now I'm going to plug my values in. So I've got the integral from -1 to 0. I have 8x on top, but on the bottom, I'm going to put u right here because that's what my u value was. So u squared. And then where I see the dx, oops, I didn't rewrite this. Oh, I did rewrite it. It just disappeared. I don't know why things are disappearing on me today. So dx is equal to du over 8x. Well, lo and behold, those cross off. So what I'm really left with is -1 to 0 of 1 over u squared. Well, I can take an integral of that. That is going to be u to the -2nd. And if I take the integral of that, what do I have? U to the -1 over -1. And then that's on the interval from 0, or from -1 to 0. But I still have to replace the u. So that's going to be 4x squared plus 1 over -1 from -1 to 0. So if I put 0 in here, that crosses out. I end up with 1 over -1. So that's going to be -1 minus, and then if I put -1 in here, -1 squared is 1, 4, so that's 5 over -1. Boom, boom. So I'm going to say that my answer is 4. Oh, darn it. Now you. Okay, so my answer is not 4. You caught me. Okay, so that's u to the -1. So my answer, so this really is going to be 1 over -4x squared plus 1 on the interval from -1 to 0. Good catch. Good catch. I was just seeing this if you were paying attention today. So now if I put 0 in here, that's going to be -1 still. minus, and if I put -1 in here, that's going to be 5 on the bottom. So that's going to be negative. So that's going to end up being, okay, so that's going to definitely change my answer. So my answer is what? -4/5? Darn it. I thought I had it. All right, so I'm going to go with -4/5 there for an answer. Okay, does that make sense? Obviously, you understand what's going on because you would have caught my answer. Okay, I'm going to let you do problem number 2 by yourself. I'm going to do it on a piece of paper. So I'm going to get rid of that, all of that. I'm going to do it on a piece of paper and see if we come up with the same answer, okay? It is an integral from 0 to 1, so you do have to come up with a value. They tell you what your u value is supposed to be, but you should have been able to figure that out by yourself, right? Because you know you have to get rid of this 2x squared. Well, if I took the derivative of 4x to the third, that's going to give me an x squared. That's going to cross off. So they shouldn't have had to have given us the u value, but sometimes they do. All right, so I'm going to let you work on that. I'm going to work it out also and see if we come up with the same answer. It would be awesome if we do. Oh my goodness. My answer is nowhere even close to yours. I ended up with -20. All right. So obviously we don't agree, right? So I'm going to be really bumming if the answer turns out to be -0.25. All right. So let's take this step by step. All right. Oops. My u value, they gave me my u value, which they shouldn't have had to. So u is equal to 4x to the third minus 1. So du over dx equals 12x squared, just 12x squared. So I'm going to solve for dx. So I end up with du over 12x squared equals dx. Okay, so far so good? Okay. Then I'm going to substitute. Okay, so I've got the integral from 0 to 1, -12x squared. And then I'm going to put u here to the third power. And then wherever I see dx, I'm going to put du over 12x squared. So far, so good. Okay. I crossed off the 12x squared here and the 12x squared here. I still have a minus sign there. Okay. That didn't go away. So I ended up with the integral from 0 to 1 of negative u to the third. I'm going to bring that negative out front because it really doesn't matter. It's a constant. I can bring it out to the front. So I'm going to take the integral here. The integral of u to the third is u to the fourth over 4. I still have the -1 out in front. Okay. Did you get to that point? Did you take the integral correct or did you take a derivative there? All right. Boy, somebody's math is not so good. So now I put the 4x to the third minus 1 back in here. Okay. Remember, you've got to put it back in here. So I've got negative 1, 4x to the third minus 1 to the fourth power over 4. And then you just put your numbers back in, the 0 and the 1 in there, didn't you? So now I have from 0 to 1. And so now if I put the 1 back in here, I end up with 4 times 1 to the third, which is just 4. So that's 3 to the fourth. So I ended up with negative 1, 3 to the fourth over 4 minus, and then I put 0 in here. And if I put 0, that's 0. So that's a negative 1 over 4. Well, negative 1 to the fourth power is positive 1, right? So that's positive 1 over 4, but I still have that negative out in front. So that's negative 1/4. So I ended up with this. 3 to the fourth is 81. So that's negative 81 over 4 minus or plus 1/4, which becomes negative 80 over 4, which is negative 20. So you did really good work until here, and then you forgot to substitute back in, because this is my integral, not this. This is not my integral. It just helps me. That's why they call it U substitution, because it helps us find, because there's no way you could take the integral of this. But the integral of this, that's not hard at all. Or what was it? U to the third? That's not hard at all. I mean, that's just U to the fourth over 4, but you got to remember, you got to plug that back in so it makes sense. Okay? Does that make, are you getting it? All right. Let's try another one. All right. This is a tricky one. What do you think your U value is? Cannot be something squared. You can use sine, you can use cosine, you can use tangent, but what you want to do is you want to let it equal, you want U to equal the sine. Why? Because what's the derivative of sine? It's cosine. That's going to cross that off. So then I'm going to use U as sine, so I'll end up with the integral of U squared. See how that, if you use sine squared, then it's like, okay, then where are you going to plug it back in? But if you just let sine be U, then if I take the derivative, I've got du dx is equal to cosine. Now if I solve for dx, I get du over cosine equals dx. If I plug this back in, I end up with the integral of this integral of U squared times cosine of x times, and then du over cosine. And lo and behold, that crosses off. So now I'm left with U squared du. Well, that's pretty easy to take an integral of. That's U to the third over 3. And then I just put my sine back in there. So that's sine to third over 3. Now, again, can I check my answer? Sure. I could take the derivative of this. Well, remember the derivative of sine, and remember I always taught you guys to do this when you had it to the third power. Okay, so you bring the 3 down. So if I take the derivative of that, I bring the 3 down, leave the middle alone, times the derivative of the middle, which is cosine, over 3. Those 3's cross out. Is this what I started with? Because I just took the derivative of this, and I got this. That is, oops, I forgot to put the square there, because if you bring the 3 down, you have to put a 2 there. So sine x squared over times cosine. So it is exactly what I started with. So you can always check your answers just by, whatever you think your integral is, just take the derivative of that and see if you go back to what you started with, because that always is going to, it has to. If it doesn't, you did something wrong. All right, let's try another one. Oh, this one's easy. Let me see if there's a harder one here. That's a little bit tougher. All right. Well, we'll try the easy one first. Okay, so let's try this one. Give it a shot and see what you get. Three x plus 1 to the 6th over 18. That is absolutely correct. Very nice. Excellent. Okay, one last problem today. This is one of the harder ones because it has an integral, or it's a definite integral. We have to go from 0 to 3, and it's a pretty good one. Give it a shot. See how far you can get on this one. Okay, I think you can get the whole thing done. I think you're there. Letter B. All right, now I was answering a couple emails, so I didn't do the problem yet. So let's take a look here. I'm going to let u equal negative 2x squared. Du is equal to negative 4x. Then I should put dx over there. So then du over negative 4x equals dx. And then I'm going to substitute in. I've got the integral from 0 to 3 of x times e to the u times du over negative 4x. X's cross off. So I'm going to be left with negative 1 over 4 integral from 0 to 3 of e to the u. And the integral of e to u is just e to the u, so that's gone. So I'm going to put it back in. So I have negative 1/4 e to the negative 2x squared on the integral from 0 to 3. So if I put 3 in there, oh boy, that's 9. That's negative 18. So I end up with negative 1/4 e to the negative 18 minus, and then I'm going to put 0 in here. So that's 0. So negative 2 times 0 is 0. E to the 0 is 1. So that's negative 1/4. Oh, they pulled the 1/4 out. Tricky, tricky, tricky. All right. So if you pull a 1/4 out, oh, they pulled a negative 1/4 out. So that would, yes. So what was your letter B? I would agree 100% with that, because if you pull the negative 1/4 out, this is what you end up with. Awesome. That is U substitution. It is one of the harder things. I mean, it really is. I will go in and I will open up your assessments for this week. I think there's 2 of them. I'm not sure. There might be 3. I'm not 100% sure. But this is U substitution. All right. Have a great week. Any questions before we go? Guess not. All right. Have a great week. Bye.